Welcome back, chat. Yes. All right. Smash that like button, subscribe, leave a nice comment below. Not a criticism, please. I'll cry. Here we go. 1.3. All right. Today we're going to look at something that you've dealt with over and over. We're going to look at linear equations, which real quick, I'm just going to pause here. Linear equations, what's the root word? Hey, it's a line. Okay, easy. Linear equations. EQNS is my shorthand for equations. And we're going to make this easy. We're only going to work in two variables. Vars is my shorthand for variables, purely because any TI calculator that you ever use will have vars as a shorthand as well. Okay, so we're going to see how much we can get through. Right off the bat, anytime you give me a line, with the exception of a vertical line, they all have some amount of steepness to them, right? Steepness isn't a word that you formally use in math, though. What's that word? Slope. So there's our first little topic, using slope. Excellent. Now, I had no idea if it's different. Anybody gone to school in a different country and talked about algebra in that school or lines? Is M the standard worldwide, do you think? I have no idea, like not a clue. It depends on the context. Sometimes K is used more commonly. But everybody okay with, in your experience, in at least the U.S. education system, use the letter M for slope? Okay, so here's the issue that I have with it. I just don't really remember anything about it. So slope is M. How do you find slope? What is it? So y over x, almost. Is there a wordy version? Rise over run, okay? With your hands real quick, just show me rise. Show me the dimension of rising. It's this one, right? You can rise upward or you can rise downward, which is called falling, but we'll call it rise still. And run does what? Just like this, yeah? Okay. So good. Rise over run. Well, that's not very mathy. I sure do like Greek letters. Do you know any? Oh my, how do you draw Greek capital delta? Hey, it's a triangle. Delta, so rise over run is the change in, gosh, rise is, what axis is this? It's y. And the horizontal axis, the run? X. Delta y over delta x. Now, you may not need to put all these, but we're just going to go through it. I want this cleaned up even further. And I'll work next to it. So y sub 1 minus y sub 2. And I'm going to pause because we're going to see two different ones. I disagree. I would prefer to use y2 minus y1. Who's right? We're both right. Why? How do we make sure we're both right? If I'm consistent with the order of my subscripting, then I'm good with it. If this is y1 minus y2, the denominator must have x1 minus x2. If I have y2 minus y1 in the numerator, and knowing it's sub 2 and sub 1, but we'll just use common language, what goes downstairs in the denominator? I am so close to yawning because I've heard you yawn like 4 times. Like, that's not a criticism or anything. Do you guys know that in school I yawn? Like, we're talking about, so everybody's going to start yawning. I yawn without opening my mouth. Here's my challenge for you. I want you to see if you can tell when I yawn. Because I will yawn because we're talking about it like I'm about to now. I want to see if you can tell. Okay. So, it's not doing it right now. It's going to happen. Pay attention to this and just see if you notice it. No, ever. Yep, I had that thought. Yep. Cool. All right. So as we're looking at this, linear equations, we write with two variables. They're x and y, right? Okay. As we look at this, I'm going to blast through this. Do you guys remember how to graph them, do you think?
Graph what?
A linear equation.
Yeah.
Okay. So I'm going to check, just see how much actual stuff you remember. And we're probably going to go through this a little bit faster. Does this ring a bell? Slope, intercept. Okay. Can you tell me what slope intercept is? So here's my challenge. 30 seconds. Chat with your neighbor. I'm going to call on somebody random. 30 seconds you have. I want to know what slope-intercept is. All right, so we're going to go real crazy here. If I want to find slope-intercept, what two things do I need? The slope and the y-intercept. I heard it right off the bat. If we need to go really into detail, we will. Y equals mx plus b. What intercept is b? Do I need to write that, or can we all recall? Okay, what's m? Deal. Awesome. Okay, give me another form of this, and like we'll do some examples with it. Ooh. What? You guys don't like standard form? You're wrong, and I'll show you why. Like, not even subjective. Like,
Do we need to leave room between the next one?
no, I don't know why I have so much room. Point slope. What do I need to get point slope?
A point is
Okay, that's a good answer. Okay, a little bit harder to recall on this one. 30 seconds, quieter, just so that if one person has it, not everybody has it. With your nearest neighbors, try to remember point slope. Really judgy. We'll see how tired you get. I know, I heard you say you just get so tired, and we're going to see if I can just maybe convince you to not get so tired. What's point slope? Oh, here, let me try. Matilda! Anybody remember? So I heard lots of good pieces with it. Check it out. We're going to be a little bit more formal with the definition. I'm not really going to make you all super self-conscious. We're going to be a little more formal, though. Let f of x is going to be a linear function, but let this have a slope of m, slope equal m. So we have a function with slope m pass through some arbitrary point. And we're going to call this point x sub 1, or sorry, x sub 2 and y sub 2. X sub 2 and y sub 2. And I suppose we'll say and x sub 1, y sub 1. I don't know why the order came out weird, but we'll just say both of them. Okay. When we're working with point slope, it is super duper easy to deal with. There are some things that we could do to move stuff around, but instead of making us derive it because we're just going to use it, I'm just going to see how much we can recall. If I do y minus y sub 1, and we might already be close to it, equals, so here's the y coordinate of a point, and it could have been y sub 2 if you'd rather, just so you know, m okay, and then different color, just so we don't get it goofed up. The subscripts are super important. This point with y1 in it and with x1 in it is the point that we pass through. The point. Which means you're never going to plug something in for y or for x. You don't have to. Only y1, x1. Okay, look familiar. Do we need to talk at length about this? Okay, because we're going to use all three and we're just going to check. There's one more form and it's called standard. I don't get that. Like, you guys, can you tell me what you don't like about standard form? Okay, if that's all that the issue is, then that's easy. But if somebody remembers what it is and you remember it, like, was it hard to graph?
Oh, it's the A.
It's ax
Yes,
plus by equals c. Now, for this, depending on how hardcore you want to go into it, we're not in an Algebra 1 class, so we're not going to go crazy. We aim to make sure that the greatest common factor of a and b is 1, so that there's no common factors that can be simplified out of it. But this is the form. That's it. Now, this one, even if you don't love it, we have to have it. And we're not talking about functions today, just so you know, but this can write a function. Point slope can. Slope intercept can write a function. But neither of those can deal with the vertical line. Because what's the slope of a vertical line? Not 0. Undefined. And like you were, yeah, I like that, but undefined's a better word for it. If you have to use m in your equation, you can't use it. You can't because it's undefined. So we need a way to be able to write these lines. So You guys say you don't like this. I'm not sure why. We're going to figure it out. We're going to do a little bit of really quick sketching here. We're almost done with the lesson. This is a super fast lesson. Am I going too fast?
No.
Okay, good. So here we go. Example. And then here's my thing for you. I don't want you guys to spend crazy amounts of time sketching. If I didn't specify this the other day, these, I'll just spread them randomly. Don't take like whole stacks, but there are graph paper that will sit at people's desks if you'd rather use graph paper. Like, bye, Jen.
I guess so.
No. If you want it, you can use it. You don't really need it because we're just sketching our graphs. Sorry. Not sorry to throw it because I meant to throw it, obviously. But here we go. We're going to look for some stuff and we're going to sketch these things and just see if we have little gaps in knowledge. Where are they? Cool. Anybody have a preference to what we, what form? Because I won't tell you this. Oh, we'll just guess one. Okay, I want the line. I'm going to say sketch linear because these are all going to be straight lines. You're good. Let's see. Well, I went through. What's your favorite non-origin point? Abijah. This is example A.
1, 2.
Good choice. 1, 2. And I want 0, -5. We have 3 options. Now I'm going to be honest. I don't like standard form if I have to write the equation for it. That direction I don't love doing. The other direction where if I give you the equation to graph, and if I say here's standard form, graph it, super easy. And we'll look at it. So easy. Yeah, 3 options. We're going to sketch this, but I also want to write the equation of it and such just to get practice. Am I going to use point slope, slope intercept, or standard?
Point slope.
Sure, I'll use point slope. Let's do it. If we want to use point slope, do I have a point? I have 2 to choose from. Cool. Do we have a slope? Not yet, but can we? Yes. How? What would you like me to put in the numerator? Numbers. -5 minus 2. And that must coincide with 0 minus 1. What's our slope? It is indeed 7. Okay, so we now have a slope of 7. And we're using point slope, you guys said, right? I'm good with that. So I'll make a little note, point slope over here. I'm just going to call it PS. What point should we use?
0, -5.
Yeah, we can. Does it matter? Nope, that one's the easier one. So I'm cool to use that one. Through 0, -5. Okay, all I need to be able to do is, you don't even have to memorize in here, just so you know. We will eventually, because the AP test you don't get note cards. Regular tests will ease into that. For tests throughout, we'll start reducing as we go. But to start, we'll get note cards and stuff. Like, we'll ease into it. Y minus something. What's the y coordinate that we chose to run through? So y minus -5 equals the slope of 7 times, what goes in this parenthesis? X minus 0. Can we simplify this if we want? Now, I want to be really clear. If the directions only said to write the equation, we have an equation here. You don't have to go any further. This is an equation with an equal sign. You guys naturally want to change this, however, to be in slope intercept, because that's more natural. Okay, I'm going to change that to a plus because it's minus a negative. Do I really need this minus 0? No, so I'm going to pretend like it's not there. How do I solve it for y? Okay, yeah, so I 7x minus 5. We're done. We're going to sketch the graph here in just a second, but I do want to highlight something. We used point slope, right? What if I didn't want to? What if I want to use slope intercept? So you say that, however, I want you to look really closely. Where is this on your graph? It is the y-intercept. If you got the slope of 7, the rest of this is fun and fine and dandy. We don't need it. As soon as I know it's 7 in slope intercept, we have 7x. What's my y-intercept again? Oh my gosh, same answer.
I would have tried to solve for it.
Everybody would try to solve for it because I'm trying to force you to do that so that we can highlight that mistake. Not really a mistake, but just maybe more efficient option. Okay, sketch it roughly. I want to see what you come up with. And if we have to make a table and stuff, we can, but I think we can do it without a table. Dolan, I love your graph, just so you know. Like, not even, like, 100% sincerely. I like the amount of time. It tells me everything that I need to without a whole lot of effort. Can I show yours up here? We're all going to have very similar graphs. And I passed out graph paper in case somebody's, like, really crazy. Not crazy is not the right word, but really particular about how your notes look. I am not kidding a little bit for the purpose of this, because this is all review stuff. I love what Dolan has in his notes. I'm not going to say you have to do it, but this is more than sufficient. Here's Dolan's graph. Is that what yours looks like? Maybe with more numbers. It crosses at -5, and then it goes up 7 and over 1. This graph is just as good as any of the other ones. If you take the time to actually do the ticks and stuff, you're putting more effort into it than you need to for notes, for homework, generally. Unless I tell you, hey, be very, very direct, make a table, graph this perfectly, you do not need to do it. You're welcome to use a graph paper because it makes it nice to draw straight lines. But if somebody struggles and you don't remember how to do this, just really quick like that. Do I have to make a table? No. From this, is there a free point that I get? 0, -5. Here it is. Now, if I wanted to use slope as the idea for how to get this, how on earth do I interpret a slope of 7? So it's 7 over 1, and what does that tell me? Rise 7, so I'd wind up at 2, I think, and then I run, which direction? Positive, they're both positive. Okay, could I have gone down 7 first? So long as I do what afterward? Go left 1, and I would get the same line. We don't have to, yes, we don't have to, better. We don't have to put crazy amount of work into these. Like, I'm going to be chill with graphs unless I say, hey, here's like the Cartesian plane, graph it perfectly, show me your table. If not, I'm good with pretty chill. Okay, do we need to do another one like this? Okay, do we need to do another point slope? We are going to do the standard because I do want to show you guys that you're wrong. This one we're going to sketch 5x plus 2y equals, let's do 10. This is a standard form of linear equation. How would you graph it? Like, don't actually do it, but if you need to think this out and you're gonna do it, I just want a strategy. I want like 30 seconds, chat with your neighbors, and I'm gonna ask somebody to tell me how we would graph this. What would you personally do? We'll go a minute if we need it, but talk.
Yeah.
You would? Okay, I have a follow-up question. Could you do it not by doing that?
No, that's why I don't like it. It gives an extra step after.
Oh,
Well, how would you graph the step? Where you, that's what we said. What's the way you can do it without doing that?
yeah.
Okay, would it work?
I do what I want.
Bad way to do it. We should already answer.
Brain, no brain.
Okay, that was my guess. I just want to see if that's what you were going to say. Whose gut feeling is something like this? Do not write it down. I'm going to subtract 5x from each side, then I'll divide by 2. 10 minus 5x over 2, and you might even do a little bit different stuff, but you would solve it for y equals, then graph it. Natural, right? Like, that's a natural way to do it. It's an okay way to do it. It is not the good way to do it. Okay, I love equations in this form because of how easy it is. You only need 2 points, right? If I had the x-intercept and the y-intercept, could I graph this? So just to remind me, if I want the x-intercept, it's when what is 0? So I'm going to write this a little bit more formally. If y is equal to 0, this implies then there'd be 5x equals 10, right? Are you guys okay with that? Does anybody not quite understand what I've just done? Yeah. If y is 0, 2 times 0, it just disappears, and I'm left with 5x equals 10. And furthermore, if I'm at y equals 0, I'm at the x-axis. Okay, those two things is what I'm going to use. I just found my x-intercept is where? Okay, or if you really want to be specific, here's my x-intercept. There's a point on my graph. What if I wanted the y-intercept? It's when x is 0. Now, I don't even cross it out. I physically, on my page, if I'm doing this, what's y if x is 0? It's 5. Or, if we want to write it out more formally, like we just did, if x is 0, this implies that 2y equals 10, again, because 5 times 0 just is gone. And then we get the point y equals 5, or ordered paired 0, 5, right? Before we move on, I'm going to give you time to digest that, see if that really truly makes sense, or if I have questions. Now, realistically, would you need to show this work to do this math? If, without writing anything, if I said, if y is gone, what's x, could you solve it? And can you remember the number 2 and then plot that number 2? You can graph this without ever writing anything down pretty much every time. You might get some ugly fractions from time to time, but just a really quick, easy sketch. Here we go. Here's a coordinate plane. We need the point 2, 0 there, and the point 0, 5. Almost. You know what? Why would I not do it like this? 5. We're done. Standard form is super duper convenient. As long as you remember, we can always find the intercepts. In fact, you're always okay to find the intercepts, whether it's slope intercept or point slope, doesn't matter. Plug in 0 for x and 0 for y, and these things come out pretty easily, pretty quick. All right, I have one more little thing to see if we remember. And last piece. What does this say? Love it, parallel lines. Now, we know that parallel lines are coplanar and they never intersect. Like, that's how we define them. We're not in geometry, that's fine. What about in algebra? We're kind of in an algebra class. Oh my, same slope. This is all I'm going to do to define this. Whoa, not that. Okay. Same slope. Now, you do run into a weird little part with this. Don't write this down. I'll just talk about it over here in bright fuchsia. Let's say I try to calculate slope and I got these. Is undefined a number? Probably not, right? Like, it's kind of weird to say it is. Are these the same slope then? Yes, even though undefined is not a number, I wanted you to feel uncomfortable about it. Two undefined slopes, they just mean vertical lines. Are these parallel even though we can't say that they're equal?
Yeah.
Yeah, the numbers aren't equal because they're not numbers. It's a weird little situation. Same slope or same undefined slope, they're parallel every time. What's the opposite of parallel? Perpendicular. Is there a symbol for that?
It's like an L, but like there's a little right.
So it's kind of like an L or just an upside down T.
Yeah.
Perpendicular lines. Okay, this one, I'm actually going to go underneath to write this because there's two situations we need to consider. Give me one thing that you guarantee makes lines perpendicular. Not just opposite, you're close.
Reciprocal?
Opposite reciprocal. Okay, somebody in here says, okay, that's fine and dandy. I have no idea what that means. Don't care who it is, but we're going to check it. As an e.g., an example of this, just to make sure, help me recall if M1, my first slope, is A over B, this is perpendicular to, gosh, what's the opposite reciprocal? Do the whoa. Right? That's every time. Okay. There's a weird situation in here because there's one place where this doesn't work. What's the opposite reciprocal of 0?
0.
Because try it. Like if I said 0 over 5 is my slope. Flip it and tell me the number. Like this is 0. I agree. If we do the opposite reciprocal, it's negative 5 over 0. Undefined. Okay. Worth noting. M equals 0. M1 equals 0 is perpendicular to M2, undefined. And I don't love that I just wrote equals undefined, but we're going to roll with it. Cool. Opposite reciprocals or 0 and undefined every time. Sweet. Okay, we just went through an entire section. Feel okay?
Yeah.
All right. Here's going to be the weirdest assignment ever. It's going to be a pain to check tomorrow. That's all right. Okay, homework tonight. We are going to call this homework 1.3, which you will find waiting for you on page 31. Okay, if I look in the text, and I'll just show it here so you guys don't have to look. Do you agree that my homework is split into sections? There's vocab, there's sketching lines, there's estimating slopes. There are graphing, like all these are different sections, right? Okay, here's my challenge for you. Page 31, I want you to do the following. We're going to do 1 through 7 first. And then I'm going to give you guys a little bit of choice in this. 1 from each section. You pick it, I'm fine with that. We'll find, hopefully you guys find a hard problem that you realize you struggle with. We won't check tomorrow the normal way. I would pick odds. Why? You can check your answers. Like, we don't have to check the answers. My hope is that somebody will pick an odd one that's not just the very first from each section. Like, you can. I'm not going to stop you. You're not doing yourself a favor, though, because if you want to really learn this stuff well and make sure that you're good at it, pick a harder problem. See if you can do it. Okay. I will ask you guys for each section. I'm going to make one more little comment. We're going to say don't go. Everybody's eyes on the board because I don't know how to write this nicely.
How many sections are
Yep, that's what I'm getting at. Stop at this section. So don't do a problem beyond 80. So only do 1 from each section. It's going to be like 7 problems plus the vocab, 7 or 8. Do not go past number 80. You don't have to do this section or this section or this section, like none of the others. Don't go beyond 80. Cool. Because you could go all the way through it. Oh, I really do like the true or false. Anyway, 1 from each section. I'm hopeful that you guys can say, oh, man, I picked this one. It was hard. Can we do this? I would love that. Cool. All right.